Okay, this is Jack Jackson. In this video, I'm going to show you how to program in an inverse probability function for a geometric distribution into the TI-nspire. Now, in the previous video, we derived a basic formula for the probability for the A. So we have this probability if x is less than or equal to A equals C. If we know C and want to find A, we have this formula. A is the natural log of 1 minus C divided by the natural log of 1 minus P. Now, unfortunately, A is not necessarily a whole number, so what we'll do is we'll round A up and down and get those two x values and find their probabilities, their cumulative probabilities, and those are going to be the interesting things that we're looking for. We're going to either be interested in the one right below this A value or the one right above this A value. I'm going to actually put in three different numbers here and make a little part of a CDF table that's going to actually have three things in it. Okay, so let's actually look at how to do this on an nspire. Okay, so here we go. Here's a TI-nspire. Now, by the way, I have a program statistics, and statistics are a document called statistics, and in this I have, for example, under variables, you see my hypergeometric CDF and PDF. I'm going to be replacing this inverse geo here with a new version here in this video. Okay, and so I'm going to save this as statistics, and then anytime I open my new document, or not a new document, but open statistics, these functions will be available for use. Okay, so here we go. So I want to find this A value, and I'm going to start by working this out by this formula that we just came up with in the last video. So it is 1 minus the C value, take the logarithm, and divide by the natural logarithm of the 1 minus the P value. If you look, that's this probability, this function right here. So that's going to be my A value that I want to look at. So for the moment, I'm going to store that as A. Now I want to adjust A little bit now. So that's stored as A. Now what I want to do is I want to, first of all, round this down. Okay, so to round it down, I'm going to go to Menu and go to Number, go to Number Tools, and go to Integer Part. So if I do the integer part of A, that will just take the decimals and just drop it off, which in this case, since it's a positive number, will be rounding down. And in fact, I'm going to go one smaller than that even. And I'm going to take that and store it as A. And this is going to be the A value or the X value I'm going to start my table at. I'm going to put three X values. This one bigger, and one bigger than that. Now the problem is this could potentially be 0 or a negative number here or something, so we don't want that to happen. So if it gets that low, I want to start my table at 1. So I'm going to enter this in, max. I'm not sure where to find it real fast, so let's just do it this way. Max of either the A that we already have or 1, whichever one of those is bigger, I'm going to store that as A. And so that's my new A, which is given by this formula. Okay, so which is really a function of both C and P. Now, I want the function that I'm going to create to generate a table. Now, instead of a table, it's actually going to come back as a matrix. So to put a matrix in, I'm going to hit Control and the parentheses thing here on the left to get the little square brackets. That's going to be my matrix, and each row is going to be in a bracket too. Now, the first row is going to have actually 4 rows, a label row, and then 3 rows of X and CDF of X values, and it's going to have 2 columns. So the first row, I just want labels. So I'm going to put X, comma, CDF of X, and this will give me a nice label there, label row. The next row, I want to start with the A value that I have defined sub here. And then I want to do the or no, not hypergeometric, just geometric. So it's geometric is GEOM. I'd rather just get it from here than from the menu right now. Geom CDF. And notice it recognizes it a function because it went from italics to straight up and down letters. And we want to do the P value, whatever it is, and then give it that X value, which is A. Now I'm going to take this and highlight it and do Control C. Go over here and do Control V. And I'm going to replace the A by, I'm going to put A plus 1 here. And then in the formula, I want to put A plus 1. And then I can highlight that. Control C. Copy. Go over, not outside, I want to be inside here. Control V is paste. And I want to change that to a 2. And this one right here also to a 2. So this is the matrix that I want. This is going to be the matrix that we have. And I want to take that and store it as, now I'm going to name my new function. Inverse, I want to do INV Geo, G-E-O. If you want it GEOM, you can name yours that. I'm going to do inverse geo. So this is the inverse geometric. Now it's all based on passing it two numbers, P and C. Because up here, ultimately, this is a function of P and C. And then P is the probability of success each trial. C is our cumulative probability that we're looking for. And now I've just defined a new function. So now let's put it to work. I can get it now from this list up here. Inverse geometric. I can give it a probability, say 0.2, and I want to see when that first reaches 0.75, the 75th percentile, so this will be Q3. So we're looking for Q3. Well, Q3 is the first time it goes above, at or above 0.75, so that would be, Q3 would be 7 here. So now the probability that actually goes up to and including 7 is actually a little bit bigger than 75%. It's about more like 79%, a little bit bigger than that. But if you go down to 6, it's only it's less than 74% there. So you can see in the table, the way I set the table up, this first number is usually not going to be the one we need. We need these. We're either going to be rounding up or down depending on our purposes. So let's look at that again. If I wanted to see what's the probability, let's say the p-value, the probability of a success each time was 0.7, and how big do we have to get so that the cumulative probability is 0.9? Well, we can see actually reaches it at 2. 1's too small. It's only 70% there, but at 2 it exceeds it at 91%. And there we go. We have our function that we were after.